Okay, let's look at the chain rule, and we're going to look at it for basic functions to a power, composition of function, and specifically with the exponential and logarithm functions. And of course, these are going to be in conjunction with the power rule, the quotient rule, the product rule. All of the rules are going to just go together now. So our basic rule, we've got a function and it's just raised to a power. And you can see this looks pretty complicated over here, but it's the same power rule as before, but because it's not x on the inside, it's a function, we have one extra thing. So the exponent goes in front, the inside stays the same, subtract 1 from the exponent, multiply by the derivative of what that function was. And that's similar to what we've got more generic when we just have two functions composed like this. We're going to take the derivative of the outside function, and the inside part is going to stay the same. And then we're going to multiply it by the derivative of that inside part. And then again, this is all in conjunction with the product rule, the quotient rule, all the other rules. So let's look at our first one here. We've got x to the fifth times e raised to the power of x squared. So product rule, e to the fifth times first and second. First one, x to the fifth, its derivative, 5x to the fourth. Second rule, this is where we're going to use the chain rule. So e to the power of x squared, its derivative, so the derivative of the outside is the exponential part. What's the derivative of the exponential? It stays the same. So e to the x squared, nothing changes. Multiplied by the derivative of the exponent, which is the inside part. So the derivative of the second function is e to the x squared times 2x, which we put together in the product rule. So the first function, x to the fifth, times the derivative of the second function, that's where we use the chain rule, plus the second function, e to the power of x squared, times the derivative of the first function, 5x to the fourth. And you're done. The next function is a natural log. It's all over here. This b and t over here is for part C. So what's the basic rule for the derivative of a natural log? 1 divided by x. Natural log of x, its derivative 1 divided by x. So now we've got the natural log of something more complicated, not just plain x. This is where the chain rule comes in. So before we had natural log of x, and the x went in the denominator. So the inside of the natural log goes in the denominator. And the numerator is now the derivative of that inside part. So the derivative of natural log of a function, the function in the denominator, the derivative of that function in the numerator, and there's no natural log, unless the natural log is in another part. Alrighty, part C, quotient rule. So over here, where my capital B and T are is where I'm doing it. So the bottom function, and I change the square root to its exponent, and the top function right there, and I did those derivatives separately. Both of those involve the chain rule, the first chain rule with a power. We've got a function to a power. So that power goes in front, the inside stays the same, subtract 1 from the exponent, times the derivative of the inside. The top function, same thing. The exponent goes in front, the inside stays the same, subtract 1 from the exponent, times the derivative of the inside. And then because this is a quotient, we put all those pieces together down here. So the bottom function times the derivative of the top function minus the top function times the derivative of the bottom, all over the bottom squared. A lot going on there, but break it down into its individual pieces and do them one at a time. Next one is a product rule. So first function is that fifth root. Second function, w squared minus w. So that first function is where we're going to have that power rule, that chain power rule. Exponent in front, inside stays the same, subtract 1 from the exponent, times the derivative of the inside. And then our second function, w squared minus w, there's its derivative. Put those pieces together. First function, nothing changes, times the derivative of the second, plus second function, nothing changed, times the derivative of that first function. Again, that's where the chain rule came into play.